Bonjour, welcome to Wahsa Citizen Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I am Bronwyn Slade. This is a pre-recorded lesson, so you can't participate live today, but you are welcome to listen on the radio at 91.9 FM or on the television at Bell Express U channel 972. Classes are scheduled Monday through Thursday from 3 till 4 in the afternoon, and we are in our 6th week of our 9-week course. At this point, you definitely should be submitting some work for marking as we are over halfway through the course. The key questions are all listed at the end of each IL lesson, so please do all of them. Some are check your understanding questions, some are activities, and most are review questions at the end of each chapter. So make sure you're looking at the list to make sure you're doing the correct ones and not doing more work than you need to. And that you are showing all of your work, you're explaining all of your thinking, giving me full sentences, complete ideas, and that you're actually answering the question that is being asked. You can do this by hand or electronically. If you'd like to write in your workbook, that is totally fine. I'm okay with that, though the spaces are small. So you decide what works for you. Make sure that I can read it. That is the most important, that you can read it and explain your ideas, but that I can read it and understand your ideas. Or you can also do it electronically. The files that are easiest for me to open are Word files and Google Doc files. Everyone has access to Google Doc through their NNEC email address. So that is one way to do that. If you need help accessing that, let me know and I can support you with that. However, if you want to use a different file type that is best for you, that is probably fine. Just let me know so that we can make sure that I can actually open your files and mark them, as that is pretty important as well. So there are 3 ways to submit your work. If you're going to do it by hand, then you can scan it. And either way, if you have an electronic file, you can send it electronically. So if you're scanning it, you can use a smartphone. If you have an iPhone, you can use the Notes app, or if you have an Android device, you can use the Google Drive app. Either of them have scan functions that are fairly straightforward. I can help you if you'd like help. Or if that doesn't work for you, you can also just take a picture. That is fine. Those files are going to be a little bit bigger and maybe harder to send, but totally fine to do. Then you can send it to me either through email at studentwork@nnec.on.ca or NCC it, to bronwyn.slate@nnec.on.ca, or you can send it through Facebook Messenger to bslatewahsa. The second method is to drop off your work into Lookout. We have a mailbox at our location 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance, so you can just tuck your work in there. The third method is to hand your work into your DEC. Then your DEC can send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my YouTube channel and my Facebook are under the name bslatewahsa. If you want to friend me on Facebook or subscribe to my YouTube channel, then you can get notifications every time I upload one of our lessons. They are recorded each time and I upload them as soon as I can after airing. Generally, I try for within 24 hours. And I put them all in a playlist called SVN3E so that you can find all of our lessons there. Also, all of the videos that I share in class that are on YouTube, I put in a supplementary list under our playlist as well, so you can access them from their original sources if you'd like. Science is really visual. I try to integrate as many pictures and diagrams and videos as I can in order to help really make everything make sense. So accessing the videos is really going to set you up for the most success. If you can't either join me live through the Zoom or watch the replays on YouTube, let me know and I can send you a copy of the videos so that you can still have the information. If you have any questions or concerns, please reach out to me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslatewahsa. My phone number is 807-737-1488, extension 2209. And you can also call toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 4 p.m., though I teach the first hour and the last hour of that time. So those times I'm not accessible. But otherwise, I'll get back to you if I miss you as soon as I can. All right, I think it's important to position myself in the context of our society and how that shapes how I teach and what I think is important. I have white settler ancestry, I have white privilege, and this means that how I interact in education, how I've been taught, how I've been treated in education settings is been probably easier than other folks. The system is set up to benefit and for folks like me to succeed. So I recognize that, and I work to not ignore that reality and how that might impact students and the people that I interact with. I think that it's important to set everyone up for success, and our education system doesn't necessarily do that. I do live in Northwestern Ontario on the traditional territories of the Anishinaabe people, and I work hard to learn as best I can from those people and their culture, the knowledge keepers in my area. I am an outsider and I always will be an outsider, so I respect that, but I do believe that there are teachings that would benefit my students, and I attempt to integrate them into our course. This is my first time teaching this course, so I have lots to learn and unlearn. I'm not perfect, I never will be. This will be a journey the entire time that I am an educator, but it is something that I am working on in order to improve this course and make it as accessible and equitable as possible. Our textbook is also Eurocentric. It is based, from my understanding, on the experiences of white people. Generally, those are the communities that are positioned within the examples. Those are the scientists that are spoken about. Those are the teachings that are spoken about are from a white perspective. This is problematic. I haven't come across any problematic language that they have used, but I recognize that there may be things that I'm missing, or there may be language that will still come that might be problematic. But I have noticed that they do ignore Indigenous, Inuit, and Métis knowledges and experiences, and that I think is really concerning in terms of the fact that all people are affected by climate change, and environmental science is important to all groups of people, and therefore we should be connecting with them and talking about their knowledges and experiences as much as we can, in terms of to get a full understanding and to really benefit from all the teachings from various communities. So it's something that I work to integrate within our course as much as I can as an outsider. Though if I'm doing anything wrong, or if there's anything that you know that I could do better, please let me know, and I'm happy to learn and grow. All right, so we are in Unit 4, the Using Energy in Our Lives unit, and we have talked about renewable and non-renewable energy sources and the costs and benefits of each of them in terms of how we use energy. Today, we will be wrapping up this unit talking about how to conserve energy in relation to both renewable and non-renewable sources, and how reflecting upon the costs and benefits and how conserving them is beneficial. So this is lesson 15, conserving energy. So our learning goals are that at the end of this lesson, you'll be able to identify and use common units of energy, and you'll understand several methods of energy conservation at home and at work. So you will understand newtons, joules, watts, kilowatts, hours, and British thermal units, and you can explain various energy conservation methods or how they work, and energy use, how to use strategies that support energy conservation. Sorry, that's a weird sentence that I wrote down. So according to our textbook, Canada ranks 27th out of 29 industrial nations in terms of energy use. So in 2006, Canada consumed 7,643 PJs, which are petajoules of energy. We need to conserve energy by using less. So we need to use the most efficient technologies, tools, policies, and equipment to change the ways we use energy. We know that the way that we're using energy is not sustainable. Even if we were able to transfer everything over to renewable energy, the chances are still we would be using too much. So part of it is reducing the amount of energy that we consume in order to deal with our situation. So this graph here is just some updated information. So I was able to find how much energy Canada uses in 2020. So this is newer information than what's in your textbook. And I think that we are at this, let's see, 1, 2, 3, 4, 5, 6. So we are the 6th highest usages of energy consumption. And this is in extra joules. So when it says 13.63, this we times that by 1,000. So that would be 13,630 petajoules compared to the 7,000, which is what's in your textbook. So that's just something to note, is that since your textbook has been published, we have increased our energy usage, not decreased it. So we're not doing great, Canada, we're not doing great. All right, so first we need to understand energy units of measure. This is a little bit more physicsy instead of environmental science, but it's all integrated, it all is connected together. So first we just need to understand what it is that we're talking about, so that when we talk about joules or exajoules or petajoules, we're like, what is that even? So to start with, we need to understand newtons, joules, watts, and kilowatt hours, and British thermal units, so that we can talk about how to conserve energy once we understand how we measure energy. So first, newtons. A newton is the SI unit of force, so the push or pull. And this is I looked up what SI stands for, and it wasn't useful. It's like scientific, international scientific something. Anyway, it's the unit of force. So 1 newton is equal to the force that will give a mass of 1 kilogram, an acceleration of 1 meter per second per second. So newtons equals mass times kilograms divided by seconds squared. So a newton will move 1 kilogram, 1 meter in the first second, 2 meters in the second, 4 meters in the third second, and this continues. So it's the force of Earth's gravity on an apple with a mass of about 102 grams. So 1 newton equals 1 apple. And this goes back to the story of Sir Isaac Newton sitting under a tree, an apple tree, and an apple fell on his head. And this triggered the idea of units of movement and gravity. Anyway, we don't need to know that. But basically, 1 newton is the force that makes for things to 1 kilogram of mass to accelerate 1 meter per second per second. Okay, so then joules. So it's the energy of work. So it's 1 joule measures energy and work. The energy used to work. So is the energy transferred when a force moves an object. This is all words that we use, but the way that we use them in science are a little bit different. So a joule is the work done when 1 newton moves an object a distance of 1 meter in the direction of the force. So a joule equals newtons times mass. So 1 joule is equal to the energy needed to lift an apple from the floor to a tabletop, which is about 1 meter. All right, kilowatt hours and watts. So a watt is the unit of power. Power is the rate at which work is done. So 1 watt is equal to 1 joule of energy produced per second. So watts is equal to joules per second. So light bulbs historically have been rated by the power which they use. So the power has been measured as watts used in an hour, a unit known as watt hour. This means that the compact fluorescent bulb rated at 13 watts uses 13 watts of electrical power in an hour. There are 360 seconds in an hour, so a watt hour is equal to 3,600 joules. So a kilowatt hour is equal to 1,000 watts. A kilowatt is equal to 1,000 watts. A kilowatt hour is therefore equal to 1,000 watt hours. Sorry, my tongue is being toasted. We measure electrical power kilowatt hours. The average household in Canada consumes about 1,000 kilowatt hours of electrical energy per month. In joules, a kilowatt hour is equal to 1,000 times 3,600, which is 3,600,000 joules, or 3.6 megajoules. And then we have British thermal units, which is BTUs. The British thermal unit is the traditional unit of heat. It is equal to about 1.055 kilojoules, or 1,055 joules. It is approximately the same amount of energy released by burning a wooden match. Today, we usually use kilojoules instead of BTUs. However, the BTU is still sometimes used to describe the energy content of heating fuels. It is also used to talk about the output of heating and cooling appliances like furnaces, stoves, barbecues, and air conditioners. All right, so those are the units of measurement. You should now be able to answer the key questions on page 119, number 1 through 3. I did not retain all that information. It's something that you can totally look up as you go if you need to. Yeah, it's fine if it's not normal for your brain, that's fine. All right, energy conservation methods. This is where we're going to go next. All right, so we are going to watch a video about light bulbs so that we can understand the different kinds of light bulbs and how this all works with energy conservation, as this is one of the primary things that people say, just use better light bulbs. So let's see if you're going to work for me today. You're probably just not going to work for me. That's just how my life is. All right, so your textbook doesn't talk about LEDs. It just talks, or your workbook just talks about other two types. But I thought it was important to sort of have a little bit of information about LEDs as well, as they are the ones that conserve the most energy, though they are the most expensive. So let's just go over some pros and cons of the three different types of bulbs that are available to many of us. So we have the light emitting diodes, the LEDs. Pros are that they use the least amount of energy and they last longer than other types of bulbs, but they are an upfront cost that is more expensive. So if it's $50 for a light bulb, that feels like a big hit. But if you think about it, they use less energy, so that's less energy on your hydro bill or your electricity bill, and they last longer, so you don't have to buy them as frequently, and that means that there's less garbage that you have to pay for. So if you were to integrate all of those costs, then they might not actually be more expensive in the long run, just the upfront cost. Then we have incandescent light bulbs, which are inexpensive, they're cheap, and they give off a pleasant light that many of us are used to, as this is the type of light that many of us have grown up with or come in contact very frequently. But they don't last very long, and they use a lot more energy than LEDs or CFLs. Then the third option is the compact fluorescents, so the CFLs. So it does use a lot less energy than the incandescent bulbs, and it does last longer than the incandescent bulbs. So they're like the in-between between incandescent and LEDs. But they're more expensive than the incandescent light bulbs and less expensive than the LEDs. But they do contain mercury, and so therefore should be recycled. So that is just something isn't great to be aware of. So this is just in terms of looking at the costs overall. So I don't know how I was talking about if you bring all of those together, is it really more expensive for an LED? So an LED, the lifespan is about 50,000 hours, whereas the CFL is 10,000 hours and an incandescent is 1,200 hours. So the watts per bulb, which is equivalent to 60 watts. So an LED is 10 watts, but remember this is all equivalent. CFL is 14 and incandescent is 60. So they're all the same amount, the equivalent of watts. The cost per bulb, an LED, this says 35 and 95 cents. It's going to range depending on where you're buying it. If you're in Canada, the US, all of the things, right? A CFL is $3.95 and incandescent is $1.25. So we get it. Yes, it's a large upfront cost. The amount of electricity used over 50,000 hours. So this says that the LED uses a lot of electricity, 300,000 and 500, whereas the CFL is 700 and the incandescent is 3,000. I wonder if there should be a dash in here between 300 and 500 because it seems awfully large, which is about $50. Yeah, I think there's supposed to be a dash in here because that doesn't make sense otherwise. For LED, whereas it's $70 for a CFL and $300 for an incandescent. So over those 50,000 hours, you're paying $50 in electricity. So you only need one bulb, whereas the CFL, you need 5 bulbs, and the incandescent, you need 42 bulbs for the same amount of time. So then the total cost between the bulbs that you need to buy and the electricity that you need to use is, for an LED, is $85.75. For a CFL is $89.75. And for an incandescent is $352.50. So even though buying one bulb is a lot cheaper than buying one LED bulb, you have to buy a lot more of them and they use a lot more energy overall, and that costs you more. All right, so now we're going to watch a video about products. Help understand what those are. Right. So obviously that's American and a bit old, but it gives you a bit of an idea about the benefits of using energy efficient products and some of them ones that are out there. So I just wanted to go through the energy guide, as many energy efficient products have this guide on them, this yellow tag, so you can understand what is going on with them, so you know what information they're giving you. So up in the top left, it's telling you the key features of the appliance. And so you can look and you compare with similar models in terms of the cost and stuff. So this just tells you that we're talking about, this label is from a refrigerator, freezer. It has an automatic defrost, side mounted freezer, and through the door ice. So if you are looking at, you're comparing to different refrigerators, having this information tells you what those features are so you can see if they are comparable or not. Then on the right, it tells you the maker, the model, and the size so that you know exactly if you're comparing similar models, if you're comparing similar size of refrigerators or whatever appliance, so you know if you're talking about the same thing or not. Then we have this middle box, which is the estimated yearly operating cost. So again, you want to compare it to similar models. So they have this range of, for this refrigerator, it's 57 on the bottom to 74 at the top, And this particular model is 767, which is in the middle, a little bit closer to the top end, opposed to the bottom end. So this is all based on averages. It's not a guaranteed, but it's just gives you some information. And then this range shows you generally what it is for similar products. Then down here, you have the estimated amount of electricity that you would use in a year. Again, this is based on averages and your local electricity rate. So if you multiply this by your local electricity rate, you can get a better judge of how much it's actually going to cost you, instead of using general averages. Having the Energy Star here means that this product is better for the environment because it uses less energy than standard models. So they're not all going to have the Energy Star, but that just tells you that information. Great, so now you can do the key questions on page 121, check your understanding 1 and 2. Hopefully you can understand about fluorescent light bulbs and then Energy Star a little bit better. Then we're going to talk about thermostats as another energy saving option. So in Canada, heating and cooling our living and workspaces accounts for 60% of the energy we use. So we all know Canada is cold in the winter, but also it gets hot in the summer. So we really are tapping into both having to heat our spaces in the winter and having to cool them down in the summer. So one way we can conserve energy and use it more efficiently is to replace manual thermostats with programmable ones. So these thermostats allow us to set the temperature in our homes and workplaces and prompting furnaces to regulate our heat. Programmable thermostats allow us to program our furnaces to generate more or less heat depending on the time of day, when people are sleeping, or when no one is home. So you're not necessarily having your furnace pumping out heat or pumping out cold air when you don't actually need it. And so that can end up saving you a lot of money and saving you a lot of energy. Whereas a manual thermostat, you set it to one temperature and then it just stays there the entire time. So then the other thing to think about conserving energy are to look at windows. So replacing old windows with energy efficient ones helps conserve energy because it uses to heat and cool your buildings. So in Canada, old windows will use 7 to 12% more energy than energy efficient ones. So the feature of energy efficient windows is that we have double or triple glazed glass with space between each layer. So we have 2 or 3 layers of glazed glass that have space in between them. And then there are inert gases such as argon and krypton, which insulate air better in those spaces between those layers of glass. Then we have low emissive coatings, which are thin metallic layers that are spread on the glazings so that this helps with the windows to keep cold air out or in depending on the season. So here's looking at a little bit of how these work. So this is the double pane glass. So we're really zoomed up really close, right? So this is the one side of the window and this is the other side of the window. And this is the glass, the space in between, or the triple pane where you have an outside window, the inside layer, and then there's another layer of glass in the middle. So we have argon inside, which helps when the light bounces in, then that dissipates, the gas dissipates it. So it means that we're reflecting more air out and UV rays in the summer, but also it traps the air in and it helps insulate the windows, in the winter so that it keeps you warm. All right, so now you can answer the questions on page 123, questions 1 and 2 about windows and the benefits of programmable thermostats. All right, so choosing to conserve energy. Some utility providers allowed Canadians to choose to pay more to use renewable energy from the grid. So this option costs more than conventional electricity because it is new and not very much available. Canadians who choose this option are telling utility providers that they support renewable energy sources. So what that means is that you tell your utility company, you say, I want my energy to come from wind power, or you don't get to necessarily be so specific, but from renewable power. And it means that you're end up paying a little bit more, but you're supporting renewable power opposed to nuclear or non-renewable energy. I wasn't able to find any programs that I could show as examples, so it's not available in our area as far as I know. If I'm wrong, let me know. Then there's also eco-energy retrofit programs. So these are municipal, provincial, and federal government incentives for Canadians to choose to conserve energy. So for example, there's the federal government offers the eco-energy retrofit program. Canadians who follow this program can receive up to $5,000 for installing energy efficient products in their homes, like windows or programmable thermostats. There's a long list of items that qualify. You can look that up online. For example, homeowners can receive $40 for each old window that is replaced by an Energy Star rated one. And then there's variable pricing. So one energy conservation program coming into effect in Ontario that is not voluntary is variable or time of use pricing. So this is in effect. It's been in effect for years. Now all homes and small businesses in Ontario have smart electricity meters. These meters not only keep track of how much electricity people use, but also when they use it. So variable pricing increases the price of electricity used during peak hours and decreases it during off-peak hours. So this is a visual that helps you know when is peak and when is off-peak. So it changes between summer and winter. So from May 1st to October 31st is what they classify as summer. And on peak is from 11 a.m. to 5 p.m. is when your electricity is going to cost the most. So this red section. Then from 7 a.m. to 11 a.m. and from 5 p.m. to 7 p.m. that is your mid peak. And then from 7 p.m. to 7 a.m. that is your off peak. In the winter, your green, your off peak is still the same from 7 till 7, but your on peak switches and mid peak switch. So mid peak is from 11 till 5 and on peak is from 7 to 11 and from 5 until 7. And then on weekends and strategic holidays, it is always off peak. So this is why getting to the habit of doing your laundry or running on the weekends or running your dishwasher overnight or things like that, you're using your off peak hours and your electricity will be lower. So using less energy during peak hours helps lower electricity prices and take stress off the grid. It also conserves energy in the long run. Large amounts of electrical energy cannot be stored, so electricity is produced on demand. Because of this, electrical systems need to have the ability to meet the highest levels of demand at all times. When demand is high, generators work all the time. At peak hours, more expensive types of electricity generation are also brought into the mix, and so this helps Ontario plan for the future. If they're seeing that there's a lot of need for electricity at certain times, then they know how to generate that more for the future. Okay, so now you can do the key questions on page 124, questions 1 and 2. So let's review, consolidate what we did today and review lesson 15, or conserving energy lesson. So we looked at units of measure. So newtons, joules, watts, kilowatts, hours, and British thermal units. So trying to remember what those are so that we can talk about energy. And then we talk about energy conservation methods. So we talk about light bulbs, Energy Star, appliances, thermostats, and windows. And then we talked about choosing to conserve energy, where you can choose renewable energy. You can use government incentive programs, or you can also be conscious of variable pricing and when you're using your energy. So hopefully you can meet success criteria number 1, that you understand the various units of measure. 2, that you can explain how energy conservation methods work. And 3, you know energy use strategies, and so that you can support energy conservation. All right, so for the key questions, this is one of the ones where you have an activity on page 125, activity 4.3. So comparing appliance efficiencies. So You're going to do a little bit of research and you're going to compare to understand about appliance efficiencies. And then page 125 as well, the review questions 1 through 8 are there. All right, so if you have any questions for me, please reach out. I'm here always to support you. You can give me a call at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. My email address is bronwyn.slate@nnec.olin.ca, and my Facebook is bslateWahsa. You can also find this lesson and all of our other lessons on YouTube at my channel, bslateWahsa. I hope you have a lovely day. Thanks so much for joining me. Miigwech.